Hello everybody, welcome into another lesson. So today we start the polynomials unit. In today's lesson we're going to almost seem like we're doing a review of Algebra 1, but it is very necessary. Today we're going to review properties of exponents, then we're going to solve some simple problems with them. So here you have a product of two of the same base. If I have some arbitrary base a raised to the m power, that times the same arbitrary base a raised to the n power, whenever you have the same base, you got a product of it to one power times the product of that same base to another power, it's just simply going to be that base to the two powers added. So you just simply add the two powers together. So a to the m, that quantity times a to the n would equal a to the m plus n. And then we have three different formulas for dividing the same base. So if I have that same arbitrary base a raised to the m power over that same arbitrary base a raised to the n power, if m is a bigger number than n, and provided a is not equal to 0, because 0 in the denominator is undefined, it'll give you an undefined expression. But if m is greater than n, then it's going to be equal to a to the m minus n. You would subtract the power in the denominator from the power in the numerator. On the flip side, if you have a to the m over a to the n, and this time the power in the numerator is less than the power of the denominator, but like before a doesn't equal 0, then this can be rewritten in the numerator just as a number 1 over a to the n minus m. And then if you have, why did I write it a sub m? Excuse me, that's not right. That's not right. It should be a to the m, not a sub m. Glad I caught that. If I have a to the m over a to the n and m equals n, then and a is not equal to 0, then you'll just get 1, because literally they would be to the same power, and anything divided by itself is 1. Now another one, if I have a to the m, that quantity raised to the n power. So if I have a power raised to a power, I keep the same base, but I multiply the two powers. So a to the m power raised to the n power would be a to the m times n power. Now, if I have two different bases inside a quantity raised to a power, so I have two arbitrary bases, a and b, they both represent different numbers or different values, raised to the m power, that's the same as a to the m times b to the m. If I have a to the negative m, whenever you have a negative power, and provided that a is not equal to 0, it's the same as 1 over a to the positive m. So if you have a negative power, you just take the reciprocal, so you would put that a to the m in the denominator. You would turn it positive and put it in the denominator. And then if I have the quotient of two different bases, a over b, that quantity to the m power, it's the same as a to the m divided by b to the m, provided b is not equal to 0, because you don't want a 0 in your denominator. And then we have, if I have two different bases inside of parentheses, a quantity of two different bases raised to a negative power, so I have ab to the negative m power, you can take that right as 1 over ab to the positive m power, which then would be 1 over a to the m b to the m, provided a and b both don't equal 0, that neither one of them 0, because that would give you 0 in the denominator. And then you have a to the 0 equals 1, so I have some arbitrary base a to the 0 power. As long as a itself does not equal 0, anything except for 0 itself to the 0 power equals 1. 0 to the 0 power is undefined. Why is that? In short, the least complicated way to explain it is if you take any number besides 0, right? Let's just assume I'm taking 1, or heck, even -5, and I'm raising it to the 0 power. I'll always get 1 back. Now, if you take 0 and raise it to the first power, or to the second power, or so on, you're going to get 0. So the idea is there's no conclusion. You can't positively define one way or another. Is it 0? Is it 1? There's no positive way to define 0 to the 0. That's why it remains undefined. So, let's do some examples here. Let's say I have something like x to the 8th times 1 over x to the 3rd. So I have x to the 8th times 1 over x to the 3rd. Well, obviously we can multiply. You would end up getting x to the 8th over x to the 3rd. Well, notice here the power in the numerator is greater than the power in the denominator. So this is going to be the same as x to the 8 minus 3, which would end up giving you x to the 5th. So the answer to this would end up being x to the 5th, because you would just subtract the power since you're dividing two different powers of the same base, and the power in the numerator is greater than that of the denominator. Easy enough. Now, what if I have something like 2 to the 3rd times x to the 5th, both raised to the 5th power? So I have the quantity of 2 to the 3rd times x to the 5th raised to the 5th power. So you have a product rule for this. So this would be the same as 2 to the 3 times 5 times my x to the 5 times 5. So this is going to give me 2 to the 15th times x to the 25th. And let's figure out what the heck is 2 to the 15th. Off the top of my head, I don't know what 2 to the 15th is. It's going to be a very large number, I can tell you that. 2 to the 15th is 32,768. So you would get 32,768 x to the 25th would end up being your answer. Alright, so what's next? I have the quantity of x squared, y squared, raised to the negative first power. So I have x squared, y squared raised to the negative first power. Well, that's, if you have it to the negative first power, that's going to be the same as taking 1 in your numerator and putting that x squared over y, x squared y squared to the positive first power. So if you have a negative power, it becomes a positive power in the denominator. Well, anything to the first power, that's pretty easy. It's just going to remain what it is. So this would turn into 1 over x squared y squared. That would be your solution, 1 over x squared y squared. Now let's say I have x to the 5th over x to the negative second. So I have x to the 5th over x to the negative second. Well, the power of the numerator is greater than that of the denominator, right? So we can keep the same base in the numerator. You'll have x to the 5 minus negative 2, which would turn into x to the 5 plus 2, which would make this the same as x to the 7th. So the answer you should get for this would end up being x to the 7th power. Alright, let's see. We have x to the 5th y squared divided by x to the fourth y to the 0. So we have x to the fifth y to the second over x to the fourth y to the 0. Well, you have two different bases, but still the same process. Notice for both bases, x and y, the power in the numerator is greater than that of the denominator. So it's going to be the same as x to the 5 minus 4 y to the 2 minus 0, which in short would end up giving you x to the first, or simply just x, y to the second. So this would turn into xy to the second. Alright, so we have x to the fourth y to the seventh raised to the negative third power. So x to the fourth y to the seventh raised to the negative third power. Well, again, let's look at the overall fact that this is a negative power. So that means you're going to put 1 in the numerator and take that x to the fourth y to the seventh, and that negative 3 turns into a positive 3 in the denominator. Now you're just going to do the rule of, if you have two bases to a power, that's going to be the same as 1 divided by x to the 4 times 3 times y to the 7 times 3, which would end up giving you 1 over x to the 12th y to the 21st. So that's exactly what that would turn into. You would get 1 over x to the 12th y to the 21st. Alright, let's see. We have x to the 11th y to the 10th divided by x to the negative third y to the negative first. So we have x to the 11th y to the 10th over x to the negative third y to the negative third. I'm sorry, y to the negative first. Well, so we're dividing bases of different powers, two different bases, but the good news again for both bases is that the power in the numerator is greater than that of the power of the denominator. So we'll keep this bases in the numerator. This would turn into x to the 11th minus negative 3 times y to the 10th minus that negative 1, which in turn would equal x to the 11 plus 3 times y to the 10 plus 1, which would end up giving you x to the 14th y to the 11th. So you should end up getting x to the 14th y to the 11th for this. Alright, let's see. We have negative 3x to the fourth y to the 0. So we have negative, wait a second, I'm sorry, negative 3x to the negative fourth y to the 0. Well, let's establish something. Y to the 0. We're going to assume that y is not 0. So what is anything to the 0 power? It's just 1. So this could just turn into negative 3x to the negative fourth. Well, that negative 3 can stay in your numerator, but that x to the negative fourth, it'll come down to the denominator and become a positive fourth. So this would turn into negative 3 over x to the fourth. That would be exactly what you get, negative 3 over x to the fourth. So let's see, we have 10 x to the third y to the fifth raised to the negative third. So we have 10x to the third, y to the fifth, all that raised to the negative third power. Well, let's look at the fact that all this is raised to a negative power. So you're going to have 1 in your numerator over that 10x to the third, y to the fifth in your denominator, and that negative 3 turns into a positive 3 for the power in the denominator. So now let's figure this out. 1 divided by, what's 10 to the third power? That's 1,000. 10 to the third is 1,000. Then that would be x to the 3 times 3 times y to the 5 times 3, which would simplify into 1 over 1,000 x to the 9th y to the 15th. So we should end up getting 1 over 1,000 x to the 9th y to the 15th. All right. X to the negative first y divided by x y to the negative second. So a little bit of a doozy here. We have x to the negative first y divided by x y to the negative second. Two different bases, and this time, here's the thing. The power of the x in the numerator is less than that of the power of the x in the denominator. So here's what we're going to do then. Let's just deal with the x first. Since the power in the denominator is greater than that of the numerator, we're going to put a 1 for our numerator, and then that'll be over x to the 1 minus negative 1, right? And then now let's deal with our y. Well, for the y, the power in the numerator is greater than that of the denominator. So this would all be times y to the 1 minus negative 2. So what you end up getting then is, for the first quantity, you'll have 1 all over x to the 1 plus 1 times y to the 1 plus 2, which would end up giving you 1 over x squared times the quantity of y to the third. And now we just do some simple multiplication. You'll end up getting y to the third divided by x squared. So what you should see here is y to the third divided by x squared. All right, let's see. So let's see here. We have 4x to the second, y to the fifth, all that raised to the negative second power. So we have the quantity of 4x to the second, y to the fifth, that whole quantity raised to the negative second power. So deal with the fact that we have a negative power first. So that means we're going to put 1 in the numerator, take this whole quantity, that 4x to the second, y to the fifth, and then that negative 2 turns into a positive 2 in the denominator for the power. So you have 1 all over the quantity of 4x to the second power, y to the fifth, raised to the second power. So now let's do a little bit of work here. 1 divided by, what's 4 to the second power? That's 16. then x to the second power, that would be x to the 2 times 2. And then y to the 5th to the second power, that'd be times y to the 5 times 2 power, which would end up simplifying into 1 over 16 x to the 4th y to the 10th. So the solution you should get is 1 over 16 x to the 4th y to the 10th. Alright, 2x squared y divided by 6x y to the negative first. So we have 2x squared y divided by 6xy to the negative first. So you have two bases, you have a base, two different constant bases which you can treat the same. If you have bases that are constants, you just do normal multiplication / division. But we have two different variable bases here, so let's split them into 3 parts. The first part, you would just have 2 divided by 6 times the quantity of, alright, so for your x base, the power in the numerator is greater than that of the denominator. So this would be times x to the 2 minus 1 times the quantity of, let's deal with our y base here. The power in the numerator is also greater than that of the denominator for y. So you would have y to the 1 minus negative 1. Alright, so what's 2/6? Well, that's going to be 1/3. And then you're going to have x to the 2 minus 1. Well, that's just simply x. And then y to the 1 minus negative 1, that'd be y to the 1 plus 1. So this would end up giving you 1/3 x y to the second. And you can put this as xy to the second divided by 3. It would be the same thing. But when dealing with polynomials in general, you're going to see it's a lot easier to make the fraction a coefficient and then multiply it times your variables. So you would get 1/3 x y to the second for the answer to this. Alright, 4 more for this. So we have 5x to the 3rd y to the 9th divided by 20 x to the 2nd y to the negative 2nd. So we have 5x to the 3rd y to the 9th divided by 20x to the 2nd y to the negative 2nd. So let's split this up into 3 parts again here. We have 5 over 20 because you have 2 constant bases here times your x bases. Now for your x base, the power in the numerator is greater than that of the denominator. So you'd have that, see, x to the 3 minus 2 times, now let's deal with your y. You have y to the 9th divided by y to the negative 2nd, while the power in the numerator is greater than that of the denominator. So this would be y to the 9 minus negative 2. So what's 5 over 20? That's just 1/4 times, let's see, x to the 3 minus 2 is x to the 1st. And then y to the 9 minus negative 2, that'd be y to the 9 plus 2, which would simplify into 1/4 x y to the 11th. So the answer you should get here is going to be 1/4 x y to the 11th by the time you do all the simplification. 3 more. All right. xy to the 9th divided by 3y to the negative 2nd times negative 7y all over 21 x to the 5th. Yowzer, we got a bit of a doozy here. Well, start by looking for anything that'll cancel. We notice the negative 7 and 21, right? We could factor out a common 7. This could simplify into xy to the 9th times negative y. Let's write that separately still. Xy to the 9th over 3y to the negative 2nd times negative y over 3x to the 5th. So that's simplified a little bit. Now, since we don't see anything readily available to cancel out, let's go ahead and do the multiplication. This will turn into the x in the numerator just stays by itself, and you have a negative 1 coefficient, so that'll actually be negative x. Then you have y to the 9th times y to the 1st. That would actually become y to the 10th. And so negative xy the 10th in the numerator over the denominator, well, 3 times 3 is 9. And then you have y to the negative 2nd, x to the 5th, so 9x to the 5th, y to the negative 2nd. Well, for the numbers, you would have negative 1/9, right? Let's separate this into 3 parts here. So you would end up having negative 1/9, which we definitely can't do anything with. Now, here's another thing. The power of the x in the numerator is actually less than the power of the x in the denominator, because in the numerator it's to the 1st power, and the denominator is to the 5th. So this would end up becoming 1 over x to the 5th minus 1 power. That quantity times, now for your y's, the power in the numerator is greater than that of the denominator, so this would be y to the 10 minus negative 2. Well, this is going to simplify into negative 1/9 times the quantity of 1 over x to the 4th. And then you have y to the 10 minus negative 2 turns into y to the 10 plus 2, which would just be y to the 12. So, since you're going to have a variable in both the numerator and denominator, you're just going to have to write it as negative y to the 12th over 9x to the 4th. That's what you'd end up getting. You would end up having negative y to the 12th over 9x to the 4th by the time you did all the simplification. And I got, let's see here, 2 more. So we got y to the 10th divided by 2x to the 3rd. All that times 20 x to the 14th over x y to the 6th. Another doozy, right? So, what I would suggest, look for any numbers that would cancel. Between 2 and 20, 2 factors out. So, This can be rewritten as y to the 10th over x to the 3rd times 10x to the 14th, 10x to the 14th over x y to the 6th. Well, why don't we go ahead now, since we can't cancel out any more numbers, let's multiply all this. So in the numerator, you would have 10x to the 14th, y to the 10th, all that divided by, so x to the 3rd times x to the 1st, so that'd be x to the 3 plus 1, that'd be x to the 4th, then times y to the 6th. So this will turn into 10x to the 14th y to the 10th divided by x to the 4th y to the 6th. Well, let's split this into 3 parts again. You have your numerical base of 10, so you'll just take 10 times, now for your x base, the power in the numerator is greater than that of the denominator. So this will be x to the 14 minus 4 times, now let's deal with your y base. Again, the power in the numerator is greater than that of the denominator, so this will be y to the 10 minus 6. So in short, this is going to simplify into 10 x to the 10th y to the 4th. So this would simplify into 10 x to the 10th y to the 4th. That's exactly what you'd end up getting. I got one more. All right. So we have 12xy divided by 7x to the 4th. That all times 7x to the 5th y to the 2nd over 4y. They don't hold anything back in this one, do they? Well, clearly the 7s will cancel out, right? Those are gone. 4 goes into 12 evenly, so the 4 is gone. That 12 will turn into 3. So this can be rewritten as 3xy divided by x to the 4th times x to the 5th y squared over y. Now, since we've simplified initially with the numbers, why don't we go ahead and multiply all this? So you'd still have 3 in the numerator. X to the 1st times x to the 5th is x to the 1 plus 5. That would end up being x to the 6th. And then let's see, y to the 1st times y to the 2nd. That'd be y to the 1 plus 2. So that'd be y to the 3rd. All that divided by x to the 4th y. So this turns into 3x to the 6th y to the 3rd divided by x to the 4th y. Let's split this into 3 parts again, because you have the number 3 times, let's see, for your x base, the power in the numerator is greater than that of the denominator. So this would become x to the 6th minus 4. And then you have your y base, the power in the numerator is also greater than that of the denominator. So you'd have y to the 3 minus 1. So it's simplified, this would become 3x to the 2nd, y to the 2nd. So you end up with 3x squared, y squared for your solution. And that's it for this lesson. Next lesson, we'll do a short lesson on what's called power towers. So I hope everyone has a great night. Take care.